Tonight I want to welcome back, many times he's been here, Dr. Bill Patzert, variously known as the prophet of California climate, Dr. Drought, Dr. El Nino, Dr. Lanata, and even on occasion, Dr. El Wimpo. Patzert is a climate scientist at NASA's Jet Propulsion Laboratory in Pasadena. His research has focused on our understanding of our planet's climate and on important environmental phenomena, including El Nino, La Nina, the North Pacific Decadal Oscillation, which I'm sure he's going to talk to us about tonight, and on long-term climate forecasts. He's a graduate of Purdue University in West Lafayette, Indiana. He also then went on from there to earn a PhD in oceanography at the University of Hawaii. He began his research career at Scripps Institution of Oceanography in La Jolla, and then he moved to JPL, where he has been ever since 1938. So he's been there for 83. No, sorry, Bill, sorry. 1983, he's been, I knew you were old, but he's been there for 32 years. He has served as a consultant to NASA, the Department of Commerce, the United Nations, and in many scientific and environmental groups. And there are very few, if any, people who have helped this aquarium more than Bill has. He has helped us with films, with exhibits, science on a sphere experiences, and even an El Nino dance. Remember the El Nino dance? That was not one of our great accomplishments. Bill is one of this nation's greatest science expositors to the public. And it's not just me saying that. 10 years ago, or no, it was in 2010, 5 years ago, the American Geophysical Union, which is the world's largest organization of earth scientists, geophysicists, geologists, etc., they recognized him for his contributions to public education on these big scientific issues. And it was a wonderful award, and all of us were very proud of him. Bill grew up in New York City. Then they moved to Long Island. He was in Freeport. His father was a fisherman. Bill used to go out fishing. They depleted all the fish stocks off Long Island. And so they moved to Michigan, lived there for a number of years, and then he went on to college. And he has had a great career, both as a scientist, but I think even more than that, as bringing science in ways to the public that educate, entertain, and empower the public to do things. Please join me in welcoming Bill Patzert.
Well, good evening, everybody. And Jerry, thank you for the inflated introduction, you know. It's always nice to have an inflated introduction. And thank you all for coming this evening. Now, we've got a big topic here this evening. The drought is really on everybody's mind. We've heard it, and we're tired of it, and what we want to know is when we're going to get out of it. And maybe I'll have a little something to say about that. So the simple answer to the question is yes, we're in, and eventually we'll be out. But there's a lot of details. Okay, now what is a drought? You know, somebody asked me what a drought was, and that's when you haven't had a date in about 2 years. That's called a drought. No, a drought is a prolonged period of below normal rainfall and snowpack. And one of the things I'm going to talk about this evening is our present drought and many of our past droughts. Really, the history of California and the American West is written in great droughts. Has got to do with what's going on in the Pacific. And in the end, I'm going to ask each and every one of you to participate, because to get out of this drought, we have, you know, some short-term things each and every one of us has to do, and some long-term things that we have to do. So instead of going to sleep during my talk, it would be good to think about what you'd like to contribute this evening about your solution to the drought. Now, how do you know when you're in a drought? Is Kevin here? Where's Kevin? There's Kevin. Okay, Now, Kevin's the manager of Long Beach Water District. This is how you know when you're in a drought, when the Long Beach water cops show up at your house and turn off your water. And you know, we might not be too far from that. No, I'm just kidding, all right? But each of us has to think a little bit about how much water we're using. Now, let's look at a rainfall record. I'm trying not to make this too complicated. This is the downtown water record for downtown Los Angeles for essentially the last 70 years, going back to 1945. And you can see on the y-axis is rainfall in inches. The average is about 15 inches a year. Here in Long Beach, it's about 10 to 12 inches. The closer you get to the ocean, the less rain you get. Now, it's kind of interesting. We can have rainfall years as low as 4 inches. A couple of years ago, we had 3.25 inches. And then we have rainfall years that are as large, over 30 inches, as much as 38 inches. So from year to year, there's tremendous swings in rainfall. But when you look at this very carefully, what do you think? More dry years or more wet years? Definitely. All right? On this particular 70-year period, 7 out of 10 years are below average. So if somebody asks you, what's the rainfall going to be next year, what will you say? Drier than normal. You wish you had those odds when you went to Vegas, all right? Now, here's another interesting thing about it. So in one way to think about it, in Southern California, if 7 out of 10 years are below normal, we're more or less in a drought all the time. All the time. All right, and let's look at this again. Now, one of the things you notice is that, if you can see it with your eyeball there, it's like from 1945 to about 1977. You notice there are an awful lot of dry years. And that was a prolonged drought. Actually, 1977 was the previous record in terms of the least amount of snowpack in the Sierras. And so essentially there, for almost 30 years, we averaged not 15 inches, but about 13 inches of rain for 30 years. And that was followed by 2 decades, the 80s and the 90s, where we actually had a lot of El Niños, where we had about 2 decades of above normal. See, it was about 17 inches. And then our present period here, which I will tell you, I contend the drought really started in 1999 or 2000, not just 4 years ago. But again, so that's kind of interesting. You had these decade-long droughts, 2 or 3 decades, but the average rainfall during those periods is only about 15% above or below normal. But it turns out that that's a lot. Now here's a little interesting factoid. In the wettest 20 years, we also had a mini drought. You remember 1987 to 1992? Now it turns out in the modern record going back to the 1870s, this is the driest 5 consecutive years in Southern California history. And so you can see that the average for that 5 years was 9.5 inches. And that was a pretty serious drought for those of you that manage water. All right, that was the famous, that's when we started painting our lawns green. All right, so embedded in these 10 to 20 year droughts, you can also, or 10 to 20 year wet periods, you can get mini droughts. So it's a little complicated. Now, see those pink arrows up there? Anybody want to venture a guess what happened during those periods? Look familiar to you? Mid-70s, the early 80s. All right. That's when Jerry Brown was first elected governor. All right. Now, I voted for Jerry Brown 4 times. Amazing, huh? Vote for a governor 4 times. The interesting thing about Jerry Brown's first term, which was in the mid-70s, he was elected into one of the worst droughts that Southern California had ever seen, which culminated in the very, very punishing year of 1997. But the next 3 years, in his second term, which was 1978, 79, and 80, those turned out to be the 3 wettest consecutive years in California, in Southern California history. So Jerry Brown was elected into his first term into a drought, and he was bailed out in his second term with 3 of the wettest years in California history. Now, what's that called? Exactly, luck. Good. All right. Now, Jerry was elected, of course, a few years ago in his first term, and of all things, in his third term, like his first term, he's elected into a drought, right? So, now, if that pattern holds, what's going to happen in the next couple of years? We're going to get wet, all right? But don't bet on it. But that's a little interesting fact. All right? Okay, so the point I wanted to make on that last slide is that a drought is not 0 water. That's never happened, all right? Or it's not even half of normal, all right? A long multi-decadal drought is only about 85% or 115% of normal, all right, over a few decades or less. But that can make a big difference if you manage water. So I call the present drought, which everybody is calling drought, I call that the mini drought in the long drought. Now, this is the Drought Monitor for the United States, and I've been looking at this for decades, all right? And what it measures is how severe drought is across the continental United States. And you can see there's a little table there. The darkest ones are the most severe, all right? And this was from last week. And so you can see what's the worst places in the United States? California, all right? This drought has been very punishing in California, also in many places in Texas, all right? And so one of the things you take from this, in some ways, every place, almost every place, west of the Mississippi is in drought. So these droughts are not local. They tend to be large, all right? They've essentially, the governor of Washington and the governor of Oregon have essentially declared droughts in their 2 states. So all the way from the Mexican border to the Canadian border, we're in drought. Texas has been in drought for more than a decade. It's been very punishing. Arizona and New Mexico are always in a drought. All right? Now here's a cool little animation that I picked up. And this shows you over a 4.5 year period how the drought developed. All right, let's look at it again. See how it builds over 4.5 years? Okay, so that's interesting. We didn't get to where we are today overnight. This drought has been building slowly. So droughts are large and droughts are slow. Now remember this pattern here of abnormally dry to exceptional drought. What I did here was I took from 2000 up to the present, and I scaled those different categories of extreme drought. The darkest colors you can see here are most recently. So what this tells you is that starting in about 2001, notice that we had 3 or 4 years here of drought. And then remember the wet winter of 2006, 2007? I think there was something like 34 inches of rain. That was followed by another 4 years here. 2010, it was wet. And then this is what we call the most recent drought, the 4 years. So what is this? All right. This is a 15-year drought, not a 4-year drought. But these droughts, they tend to wax and wane. They come, you get a little relief, all right, they come back. But notice that each time it comes back, it gets worse, all right? So these wax and wane, these droughts do, all right, with some wet years. Actually, 2007 was one of the wettest years in LA history. All right, this is pretty dark, all right? This is the temperature of the state of California, average temperature of the state of California, going back to 1900 up to the present. And you see it goes up and down, a lot of spikes, all right? Those are usually El Niños and La Niñas. You see one of the warmest years on this chart was 1934. In that period, that was the famous Dust Bowl drought. You notice that. But look what happened in the last 3 years here. It's been abnormally warm for the last 3 years. Last winter was 2 degrees Fahrenheit above normal. That was unprecedented, all right? But there's also a trend. It's getting warmer from the beginning of the century to the new century, all right? So this particular drought is a scorcher. The thing that made this drought unique, it was so hot, all right? And the other thing is, the climate is changing. We're all living in a warmer world. The world is warming, and you can see it there. It's about 2 degrees Fahrenheit over the last century in California. Now, my colleagues and I have published a paper on this. So California is getting warmer. So what do you think the impact of that would be? Somebody want to take a guess? Can't hear you, got to speak up. It's a worse drought, but why? Well, you got half the answer over here is evaporation, all right? But, of course, the simple answer is, when it gets warmer, there's less snow. So the thing that made this drought so bad this year, going into the spring, summer, and fall, this shows you the percent of normal snowpack. All right, so here were this is kind of interesting here. 1985, the wet years here in the early 80s, so I call the wet 80s. All right, and then remember the mini drought from 87 to 92, which was also low snowpack, and then the El Nino years in the late 90s. But recently, remember we talked a little bit about how this drought waxed and waned? So here's the 3 parts of the drought. There's the early 2000s, here's the middle, and here's the last 4 to 5 years, all right? So basically, if you look at it this way, all right, the snowpack has been steadily decreasing, all right? And so there's 2 really nice droughts in there. Or, the other way to look at it, there's 4 really nice droughts, all right? So, if it's hot and it's dry, what happens is you get puny snowpack. Now, usually the snowpack is about 30% of our available water. This essentially is a reservoir in the mountains. So as it slowly melts during the spring, it flows into the rivers, into the reservoirs, and it supplies about 30% of our potable water in California. But this year, there is no snowpack. It's never happened before. All right. All right, now, so let's put it together. So hot plus dry, all right? What impact has it had in the 20th century? Again, this is 1900 up to the present there. And you see, this is an index that adds heat, all right, plus rainfall together, all right? So red essentially tells you the intensity of the drought. Now, it's kind of interesting here over the century, because as it's warmed up, the snowpack has gotten punier and punier. And so at the early part of the century, the wet years were more intense, all right? Here are the Dust Bowl years. Here's the Dust Bowl drought, right? Here's the drought that started right after World War II, all right? Right here, it pulsed, all right? Here's the mini drought, 87 to 92, and here's the present drought. But notice that the wet years are getting punier and the dry years are intensifying. And that's mostly because it's getting warmer. You're living in a warmer world, And so there's less snowpack. And so droughts are intensifying. So this is the preview of coming attractions and really brings home the point that looking into the future, we have to manage our water more intelligently, all right? Because this is essentially the trend for the future. And of course, the other great source of water, we store water in reservoirs. Lake Oroville is our largest reservoir in Northern California. This was taken earlier in the year, and you can see it was at 20% of capacity. So right now, the reservoirs are very low, and the reservoirs in the mountains, what are those called? The snowpack, right? They don't exist, all right? So we're definitely on the ropes here, looking ahead for the next 6 months. Now, there's been another impact, is because the snowpack is so scarce, the groundwater levels in the mountains are very, very low, as well as elsewhere. And so the national forests are extremely stressed out. And so when those great conifers in the national forest don't get enough water, they don't produce sap, and so the bark beetles take over. And so we've got millions of dying trees, not only in the local national forest, but all over the West. And so everybody really has to be careful, all right? Because remember, 95% of all fires are caused by humans, either inadvertently or intentionally. But I think we should definitely be in for a huge fire season this year. Now, here's another one that nobody likes to talk about, all right? And in California, when the great glaciers and the great ice sheets receded during the Pleistocene, 10,000 to 100,000 years ago, they left tremendous deposits of gravel, silt, and sand, and tremendous underwater deposits deep under the San Joaquin and the Coachella Valley. All right, and essentially the gravel that serves as our groundwater basins, for instance, under Long Beach, all over Southern California, except San Diego County, all right? And for more than a century, we've been drilling water out of these deep aquifers, which do not get replenished under normal rainfall. They've been there for 10 or 20,000 years, and nobody knows how much water is there. But essentially, the state of California and farmers in the Central Valley and golf courses in Palm Springs have been living off this aquifer water. So the big question looking ahead into the future is what I call the infinite aquifer myth. This is never bookkept, all right? But it's part of the inventory of water that sustains California agriculture and many communities in the high desert, right? And sooner or later, it's like when you go to In-N-Out Burger and you get to the bottom of your chocolate shake and you hear that sound, all right? One of these days, those deep drill holes in the Central Valley will do that, all right? And so that's something that nobody is really thinking seriously about at this point. But we've been doing it for 100 years. California agriculture would not exist if it wasn't for that ancient water. And it's not bookkept whenever we talk about water. Okay, so this is what I call the recipe for disaster, all right? The reservoirs are low to empty. The snowpack is essentially infinitesimal. The groundwater in many communities is at very low levels. Fortunately, here in Long Beach, you have good water management, and so you're in pretty good shape with your groundwater, even though you're going to have to use it sparingly, all right? The deep aquifers, the reserves there are totally unknown. And the Colorado River, which supplies 25 to 30% of the water in Southern California, is in deep drought, and as I'll show you, has rarely been at a level as low as it is. Right now, I think we're still at 100% allocation from the Colorado, but that might change. Now, you know, just to scare the bejesus out of you, right? It's good to know a little history. when we look back in tree ring records, this is a tree ring record that goes back to 800. This is 800 AD up to the present. And what they do is they look at these tree rings, and essentially this is the average for the American West. And that's good because I told you when these droughts happen, they are large. And so a couple of places really are pretty useful just to describe the big picture, all right? And so what happens when you look at this, during that period from about the birth of Christ, all right, till about 1,000 years ago, the earth was warming. It was called the medieval warm period, all right? It was a very good period in Europe, all right? It gave rise to the Renaissance. Things were pretty stable. But in the American Southwest, it was a time of dreadful drought. So notice there in the 12th and 13th century, we had periods there where we had century-long droughts. That's what's called a mega drought, all right? And then as we started to cool off, things got a little better. But, for instance, during that period, there was a 100-year drought on the Colorado. That's one of the great Anastasi communities on the Colorado, the cliff dwellers. They had to abandon their homes because of drought. And so also during that period, many civilizations in Mesoamerica disappeared. So this was a big drought. It was all over Central America as well as the American Southwest. And so what's the point? The point is that you can feel pretty good about this drought because I don't think this is a mega drought. But mega droughts do happen, all right? So be careful, all right, is that it's good to study history to see what's coming. Now, here's an interesting question. Did anybody see this drought coming? What do you think? All right. Now, you know, one of the things I hate, didn't you always hate it when your mother used to say, "I told you so"? Yeah? It's like one of the worst things that anybody can tell you, "I told you so." But let's look at this. Look at that. That's a good-looking young guy, Jerry. Yeah? A few years ago. All right. This is the front page of the Pasadena Star News. And you notice what he said. Water shift spells drought. Looking out into the Pacific. All right. All right. JPL says the Pacific holds the key. Now, what was the date on this? Oh, look at that. Yeah? Look at that. He said, I said it 13 years ago, and we're in the 15th year of the drought, okay? So the only thing I want to say about that is, I told you so, yeah? Okay. But don't worry, nobody really took me very seriously, you know? Except the Pasadena Star News, all right? All right, so what's the point? The point is that these droughts might be predictable, all right, if we understand what causes the droughts. Now, that's what I get paid the little bucks for at JPL, all right, to study how these great droughts are driven, what starts them, what terminates them. All right. Now, one of the things, I don't know if this is in the right place here. Let's see. No. Oh, guess what? We got the wrong talk. I knew this was going to happen. Okay. That was my Girl Scouts talk. Okay. Thanks for being patient. Okay. Okay, so now, here we go. Here's the big question. Why are we in this drought? How did we get into it? And suppose I told you it's the PDO. What would you say to me then? What would you say to me? What is the PDO, all right? All right, so I'm going to try to give you, I hope, an understandable explanation of what's going on here, all right? Now, a couple of really smart marine biologists at the University of Washington looked at 100 years of sea surface temperature data for the Pacific. And they did a fancy statistical analysis of the data, and what they came up with was two really big patterns, this is pretty cool, is that you notice in one pattern on your left, there's like a wedge of warm water coming out from the Americas. You see North America up there in the upper right-hand corner of the sphere. And that's sort of surrounded by a blue horseshoe of cooler water. Now, on your right, you'll see that that pattern can switch, and it turns to green or blue, which means cooler, coming off the Americas, surrounded by a red or warm horseshoe. So it's the same pattern. It's just flipped, all right? The one on the left is called the warm phase, or the positive phase, of the Pacific Decadal Oscillation. It's a tongue twister, huh? And the one on that one, what happens is the equatorial Pacific gets very, very warm. And since most of the ocean is in the tropics, it actually gets so warm that it actually warms the Earth. It's that warm, all right? It looks like a large El Nino. Whereas the pattern on the right, it turns cool in the tropical Pacific, and it tends to cool the Earth. Now, this sort of looks what it looks like in time. Now, this is 1900. Now, this is where you gotta pay attention. 1900 up to the present. Notice that here in the mid-1940s, essentially to the late 1970s, it's in this blue period. So it looks like that during this 30 years. Now, in the 80s and the 90s, when it was wet, it looks like that. Since 2000, it mostly looks like this. So it's switching back and forth very slowly over decades between these two patterns. All right? So our present pattern looks like that. It's cool in the tropical Pacific, warm in the North Pacific. The same thing from the mid-40s to the late 70s. Remember, that was a period when it was also in a drought. In the 80s and the 90s, those were two of the wettest decades we've ever had in Southern California. It was more positive. Actually, it looked like a big El Nino. Okay, now what I did was I took this pattern here, which tells you which of these two, which phase of the PDO it's in, and I overlaid it on LA rainfall, all right, going back to the mid-1930s. Now, isn't that interesting? When it's a negative PDO or a cool PDO, remember, we were in this period where about 30 years it was below normal rainfall. During World War II, notice how wet it was? That was the Great El Nino of 1941. Had a big impact on World War II, by the way. Notice in the 80s and the 90s, it tends to be wet with the mini drought from 87 to 92. And recently, the last 15 years have tended to be negative. So this pattern very much correlates with rainfall patterns in California, right? So when the positive PDO is around, LA or California tend to be wet. when it's a negative PDO, it tends to be dry. All right? Now, why is that? Because these large patterns in the Pacific tend to control the temperature in the Pacific, which covers 30% of the planet, tends to control the jet stream patterns that deliver the weather over North America. So when you're in a negative pattern, you tend to get blocking high pressure. Remember, for the last 3 or 4 years, all you heard Dallas on ABC talking about is the blocking high pressure system. There it is right there. Also called the ridiculously resilient ridge, all right? And the other half of that is the jet stream swoops out of Canada into the upper Midwest and the Northeast. And so they have punishing winters, frigid, heavy snowfall, where in the West, we tend to have very warm winters and very dry winters. Now, this is a pattern that we have seen over and over again in the past century. And it seems to be very highly coupled with this PDO pattern. And that's why back in 2002, when the PDO shifted, I forecasted a decade or two of drought in California. Interesting. So that was the negative PDO that we were in last winter, all right, which looks like a large La Nina. And El Nino is what? Usually is wet, right? And La Nina, I always call it the diva of drought, La Nina. They tend to be dry, all right? Now, if you need a little proof on the impact, the longer, larger impact of the PDO, look at Lake Mead. Now, Lake Mead, in the last year or so, hit its lowest level in history since it's been filled, which was back in the mid-1930s. They started filling it, all right? This is what it looks like today. That's the great ring around Lake Mead. Everybody been to Lake Mead, Hoover Dam? Make sure to go before you die, young people. It's one of the great places in the West to visit. It's really fantastic, all right? Anyhow, there's a ring around. How do we get the ring around the tub? All right, the top of the ring is where it used to be, all right? The bottom of the ring, of course, that's just mineral deposits where it is now. That ring is about 140 feet, which turns out, although the lake is much deeper, it's about half the volume of Lake Mead. So when it goes that low. So it's at about half its volume right now. Now, when it was at its highest, that was in 1983 and 1998, when we were in peak of the positive PDO, all right? 1983 and 1998, you'll both recognize as big El Ninos. In 1983, Lake Mead almost overflowed Hoover Dam, actually. They were scrambling to let water out. And here we are today, in negative PDO. Okay, so what does this mean? I told you that these droughts are large, these droughts are long-lasting. To drop 140 feet, you can't do that in 2 years, 3 years, 4 years. The fill time on Lake Mead is about 17 years, all right? So the only way you can drop it that far during this time period, if it's a very slow thing, all right? And that's what the PDO is. So you can't do this in a 1-year drought, a 2-year drought, or a 4-year drought. You need a 15-year drought. And so there it is. There's proof of the PDO, all right, and a proof that we've been in a drought for 15 years, all right? 39% capacity right now, all right? So here's the $64,000 question. If anybody understood anything I said, when does the drought end? There it is, right there. When the PDO shifts, all right, that's when we're out of the drought, okay? Because we've been in a negative PDO more or less for 15 years. What we want now is a positive PDO, which will tend to steer the jet stream patterns more into the American West. It'll be wetter along the southern tier of the United States, and then the Northeast and the Midwest will finally get a break from their punishing winters. All right. So, again, this is what happened in 2000. We went from a positive PDO to a negative PDO, all right? That's why I made my big prediction. Now what we need is to go from a negative PDO to a positive PDO. All right, now here's where I give you the good news, all right? But first you have to wait a second, because here's something really interesting. The PDO is important for a lot of reasons. Now, anybody recognize what this curve is? It's the average temperature of the surface of the Earth. Some people call it the global warming curve, all right? Some people call it the global temperature curve. And this goes back to the 1880s. And basically, the temperature is rising. So this is the trend. And it's not that much. Temperature is only rising 12 1,000ths of a degree Fahrenheit per year. So 100 years gives you 1.2 degrees Fahrenheit. That's about right. But the curve doesn't really look like that. Notice during the 1980s and the 1990s, it was much more rapid, the climb in temperature. It was about 4 times more rapid than the average. Temperature was really accelerating, all right? But then notice from 1945 to the late 1970s, what was actually happening to the global temperature? It was going down. So when I started my career, they were talking about a new ice age, all right? So, but let's try to remember here. The mid-1940s to the late 1970s, all right? The 1980s and the 1990s, what was happening during that time? See if anybody remembered what I said. By the way, right now last 15 years we've been in what's called the hiatus, where global temperatures haven't changed very much, all right? By the way, that was the first Earth Day, 1970. Ironic that in the first Earth Day in 1970, we were talking about global cooling. All right, now I'm going to make it easy on you, all right? So these are the phases of the PDO that we talked about that correlated so strongly with rainfall in California, all right? And I told you when we're in a positive PDO, the tropics get warm, and it actually warms the Earth, right? Now notice that the Earth is warming. Look right above it. The temperature is increasing rapidly. The Earth is cooling. It's a drought in California. The Earth's temperature is what? It's actually decreasing. Here's a positive PDO, acceleration. The recent drought, it goes flat again. Interesting, huh? So the PDO not only is affecting rain in Los Angeles, it's affecting the global temperature, all right? And so this is where the global warming deniers say, well, global temperature hasn't risen much in the last 15 years. Global warming is all over. Oh, no. It's just the negative phase of the PDO, and it's a drought in California. All right? So the PDO actually modifies the entire temperature of the Earth because these temperature patterns are so big and the Pacific is so big. Now, so the Earth is warming, California is wet. Earth is cooling, California is dry. See the pattern? Goes with the PDO. Pretty cool, huh? So, if you can track the PDO like we do at JPL from space, we should be able to forecast how rapidly global temperatures will be rising, all right? Or if they'll go into a hiatus or actually cool off, and what the rainfall patterns might be in the coming decades in the American West. Okay, now that we got through that, we just published a paper on that, by the way, explaining the hiatus in global warming or global temperatures. It's going to be published in Science, all right, next month, which is very cool. Okay, so here's the positive PDO pattern. Now, this is what I do for a living. We fly a satellite that measures the heat in the ocean, all right? So that's the theoretical PDO pattern. This is what it looked like last week, the Pacific Ocean. Notice the very warm spot near the equator? That could be potentially an El Nino building for next winter. All right, next winter. Not only that, you see all the warm water along the coast of California, North America, and the big cold water off cool water, and warm water off Central America going out into the tropics, cooler water. This looks very much like a switch from the negative PDO to the positive PDO. Okay, now it's a little early to say that this is going to stick around and give us a couple of wet decades, but this is the biggest thing I've seen in the last decade in terms of heat content and temperature patterns in the Pacific, all right? And in many ways, it's kind of interesting because the temperature changes off California really have been going on for more than a year. And often, the marine ecosystems will shift before you see it in the large-scale ocean data. So in some ways, the seal pup starving is a signal of a shift potentially in the PDO. Now, I don't want everybody here to cash in their 401k and bet on a wet winter, all right? But this is pretty hopeful at this point. And I'll be saying more about that probably this summer, all right? So, you know, of course, that's what Kevin, this is what we all like, a nice big El Nino. You know, who wants to test our water conservation skills for another 10 years? I'd rather have a positive PDO and a big El Nino. So I call El Nino the great wet hope, all right? And that'll all depend on what I call the big switch, from a negative PDO to a positive PDO with a potential for El Nino. That would be this coming winter. So we still have to get through the next 6 to 8 months, all right? There's no quick fix here, all right? Okay, that's it. I hope you sort of got that. But now yeah. But now, you know, since this is a talk about drought, we're in or out, I talked a little bit about Mother Nature and drought, all right? But there's a second component to drought that's equally important. And what is that? Exactly, us. There you go. It's one of my good students there, all right? All right, so the top panel is a picture I took from Mount Wilson in 1902, okay? And so you can see, you know, that LA was not that visible at that point. And this is a more recent image. And so, what's the point? There's been tremendous growth. This is, by the way, the top image. There was less than 100,000 people in Los Angeles. But since 1950, the population of Southern California has quadrupled. It's gone from 5 million, all right, to 20 million. So that's a lot of thirsty people, right? And all this growth increases demand on everything, not just water, energy, all right, all kinds of other resources. And so it's put a strain. But luckily, we've had a number of droughts since 1950, and Californians have learned to conserve water. So one of the good things about the previous droughts, it turned us into water conservation people. Not all of us, all right, but a lot of us, all right? But the point here is in a semi-arid region where 7 out of 10 years are below normal rainfall, all right, growth all by itself creates a sort of drought. Now you want an example. Here's the Colorado River water supply. That's the blue curve, all right? And this goes back to 1923, all right? And then the red curve, all right, is the demand on the resources, all right, usage of Colorado River water. Now, an interesting thing happened a few years ago. What's that? That's a supply and demand curve. Anybody ever go to school? What happens when this, supply and demand curve cross each other, you know? All right. There's more demand than there is supply. So that creates a drought, all right? Demand is greater than supply, all right? So here's a little formula I made up for you. I like to make formulas, all right? is that W, which is water, or it could be energy, all right, equals P, which is population, multiplied by A, multiplied by T, all right? So what does that mean? Is that demand equals the growing population multiplied by a growing affluence. We're all living better than our parents and our grandparents did. Well, not all of us, but all right. The point is there is more affluence. Bigger houses, larger lawns, more stuff, big screen, flat screen TVs, iPhones, multiplied by the technology. And so the demand is not just population, it actually goes exponential. It's bigger than population. All right. And, you know, in spite of all this, California is the 7th largest economy in the world. 7th largest economy in the world. The economy of California is bigger than the economy of France and Russia, all right? So we're booming. But the limiting factor is going to be water, all right? And we might be coming against the stops here. So what happens to the water in California? Let's look at 100% of, here's another formula. I like formulas, see? 100% of the water. Right off the bat, the EPA says that 25% has to go to the environment. We can't let the rivers run dry. We have to take care of the wetlands, the rivers, all right, the ecosystems. Then after that, 60% goes to agriculture. And then what's ever left over goes to urban users like us and industry. All right, that's just the way it is. And then the thing that's not bookkept here is the great aquifers, which nobody even knows how much water that is. All right? So now, you know, the big thing people say, is that fair? All right? Why should agriculture get 60% of the available water, which, you know, or it's actually 80% of the available water, 60%, all right? They get more than the lion's share, all right? So the 800-pound gorilla here, of course, is agriculture. All right, now you're probably going to think that I'm going to make fun of agriculture, all right, and try to get our water back, all right? But not yet. Let's just look at how we use water in the state of California. Now look at the first line and the third line. You put those two together, that's all the water for all Los Angeles, all right, and San Francisco combined. And then look at the bottom line. That's the amount of water that's just used to produce only almonds in the state of California. So that seems a little irrational, doesn't it? That so much water, especially since 70% of those almonds are being exported overseas. And so there's an awful lot of water going into agriculture in the state of California. All right? So, but on the other hand, droughts are pretty painful, all right? And when the well goes dry, all right, I always say the hardest working people in California are probably the ranchers and the farmers, all right? And so I'm thinking big ag is using all the water, but there are a lot of small communities that are attached to wells and family farms and family ranches, all right? So, in fact, under this drought, who's really suffering the most are the farmers and the ranchers. Not all of them, all right? As much as we might complain about those almonds. But really, I contend that the cities really haven't felt the pain yet. The water managers probably have, but you and I really haven't, all right? Because I don't know about you, but my neighborhood, the lawns are green, all right? And quite frankly, my neighborhood looks like a rainforest, all right? So let's take a look at it here. How much water does each different California cities use, from the most down to the least? So Santa Cruz has got a drought. They do pretty well, all right? And Long Beach, interesting, Long Beach does pretty well here, Kevin. But, you know, there are some bad places. Palm Springs, look at that. You know, with 123 golf courses, with 5 inches of rain a year. You know what? You know how much water it takes to maintain a golf course in Palm Springs for a year? It's 300 million gallons a year per golf course. All right? All right? So some people are doing their part, some people are not. All right? And so the use of water is not fair, it's not equitable. Some communities are responsible, some are not. Generally, wealthier communities tend to be irresponsible. Poor communities tend to use less water because they can't afford it, all right? So in Beverly Hills, they use 400, 300 gallons per person per day. In Compton, they use 50. So, you know, that's part of the water story. So this is the part where we get to chat a little bit about water, all right? Now, I've been up here a long time, you know. I hope most of what I told you is true. Maybe everybody's learned a little bit, all right? But now I'd like to hear from you, all right? So there's two ways we're going to have to deal with this drought. It's in the short term, that's the next year or less, and then in the long term, because there are systemic problems with how we deal with water in California, all right? And so those will be the harder ones to deal with. Just to kick it off, all right? All right. Oh, yeah, let's do this. All right, now I ranked here what I thought were the main drivers in water temperature and energy in California. What's the most important thing? Nature. That means natural variability in climate, population, growth and technology. And then as the large urban areas grow, they create their own heat and their own air problems. Then you have natural things like El Nino. And then you have decadal things, that's 10, 20, 30-year things. And at the bottom of the list is global warming, although you can see it's having a big impact on the snowpack. But as we look out to the future, notice I changed the order of things. As global warming increases and becomes increasingly more important, it'll be affecting not only temperature, but it'll be affecting rainfall as well as other things. And so in the short term, all right, we have to deal with natural climate variability, but in the long term, it'll be man-made climate variability, all right? So in the short term, it's a no-brainer. What do? We use less water. Think more, use less, you know? By the way, I was saying the same thing at Earth Day in 1970. Think more, use less. Yeah, all right? Now, do I think we can get through this drought? Do I think we could all get together and save more water? All right? This is a little something I said on TV last week. I think that Southern California, with one hand tied behind their back on one leg, all right, could definitely cut their water consumption by 25%. No sweat. Both inside your house and in your yard, all right? There's no doubt that we could do it, and it wouldn't be that painful, trust me, all right? All right? But remember this, on the other hand, a 25% reduction in urban water use, which is only 12% of the state total, right? What's 25% of 12? All right? It's only a 3%, so if we cut 25%, it's only a 3% reduction in the statewide total. Not to bum you out, but just a fact. Okay, let's look at a little low-lying fruit. What are the biggies? This is your house. This is where your water is used. Toilets, bathing, laundry, dishes. Okay, what are the two biggest things? Bathing and toilets. Take a couple of bricks and throw it in your toilet. If it's yellow, let it mellow, all right? When you're taking a shower, wet yourself, soap yourself, turn the water off, all right? And do it again. No sweat. You can do that on one foot with your arm tied behind your back. Every one of you can do it, all right? All right, so the 20-minute shower to the 5-minute shower, not too bad. Nobody's going to stink too bad, trust me, all right? You get to do it every day, all right? Now here's another one. I'm doing all the talking here. Somebody should interrupt me. Some people say water is too cheap, and it is pretty cheap because water in the state of California is heavily subsidized by the federal government and the state government. So you got some of the best, cheapest water in the United States. It's a good deal, all right? And it tastes good, all right? But some people say, let's just price it higher. What do you think about that? Anybody have any ideas? If we make it more expensive, we'll use less. Is that a good idea? Why not? Well, that's, you're half right. Rich people will use it because they can pay for it, all right? So the trouble with pricing water, among a number of legal problems, it's unfair. Because some people, no matter how much water costs in Beverly Hills, you know, if the only thing you do is make them pay more, all right? Whereas the little people, which are already being squeezed, all right? So, yeah, but there are other aspects. Anybody else have any ideas? What else we could do?
Well, I was going to say people might try to actually kill the water to keep the prices high. But the other thing I was wondering about is the effect of fracking. The impact.
Fracking. You think that's good or bad? Okay, fracking. Here's fracking, all right? Here's the fracking guy, you know? You know, he looks at it like it's half clean, all right? You like that, all right? Fracking is a big deal, yeah? Fracking takes a lot of water. I mean, a lot of water, all right? And some of the richest oil shales in the United States are located in the South San Joaquin Valley. Not only that, they're located right under Long Beach, Southern California. And anybody know if they're fracking in LA already? They are. They're already fracking. And so it's coming to your community soon. And so you're going to have to decide whether you want your groundwater basin polluted by frackers, right? Aside from the fact that they use a lot of water, they have the potential of doing a lot of environmental damage. And so this is going to come up in ballots, I think in communities all over Southern California. It already has, all right? But they are fracking. They're fracking in Long Beach yet? I think they are, actually. All right, because there's a lot of oil in Long Beach. Yes?
Is there any way legislatively that we can reduce the exporting of almonds?
You have to talk real loud.
Is there any way legislatively if something from so much water is used to produce almonds and they're mostly being exported to reduce the amount of the exporting of the almonds, or just because we talk about the people that are producing almonds have to pay more?
You want to legally reduce the production of almonds.
Or they have to pay higher for the amount of water that they're using.
Well, it turns out that the people that are growing almonds own the water that the almonds are growing on, all right? And so that's just California law, all right? So most of the water is being owned by the almond farmers, all right? And the other thing is that it's a luxury item, and it's highly profitable, but they're drilling so deep now for water in the San Joaquin Valley, they've actually, in some ways, had to switch to these high profitable crops like almonds, walnuts, all right? Because it costs so much to drill these deep wells into the ancient aquifers. All right? And so there's no simple way to what you suggest, you know. The governor's not going to tell them to stop growing almonds. Right? As long as they have water, they're going to grow almonds. All right? Okay. So, all right. All right, let me get to the bottom line. All right, Jerry wants me to hurry along here. I'd really like to have everybody's ideas. But my idea here in the long run, all right, in the end, this is America. If you want change, you want things to be different, all right, you have to change the laws, all right, and then you have to enforce those laws. And so the bottom line, like with everything else in America, it's whoever you vote for, all right? All right, so if you want change, you got to institute change. So the most important thing you do is not necessarily low-flow toilets or losing your lawn or showering together. Probably the most important thing anybody does is who you vote for, all right? And so that's my bottom line on water.